Hi guys, we are going to write equations of exponential functions today given a graph. Our first question sets up kind of a scenario for maybe a little bit easier of an understanding before we just get some basic graphs. So we have two species, X and Y. The population is represented on the Y-axis and the time on the X-axis. Our first question says, what are the y-intercepts for the graphs of species X and species Y? So notice on species X, our y-intercept is here at 5, whereas on species Y, our y-intercept is at 25. So 5 and 25. It says explain what these y-intercepts tell you about the population. So remember the y-intercept is the initial or the starting population. So at time 0, there was 5, however many of the species X, where at time 0 in species Y, there was 25. In our equation, that initial population or starting value is the A in the equation. So keep that in mind. That y-intercept is A. The next question asks us to find the growth factors. So the growth factors are the B in our equation. You can see that initially we started at time 0, we had 5, and now at time 1, we have 15. So we have grown 3 times in 1 year. And that trend continues at year 2. We're at 45, and 15 times 3 is 45. So you can see the growth factor for species X is 3, whereas the growth factor for species Y is going to be 2, because you have this coordinate here at 150. So when we went up a year, our species doubled. It started at 25, and now it's 50. So we have a growth factor of 2 for species Y. So it says which species is growing faster? Well, of course, species X is growing faster because it has a larger B value. Again, this is the B value. So we have the B value and we have the A value. So we have what we need to write our equation. So the equation for species X would just be 5. Remember, A is the initial or the y-intercept. B is how much it's growing by, and it's always to the x power. Whereas for species Y, our initial value, or A, or again on the graph, it's represented by the y-intercept is at 25, and its growth factor, or B, is 2. It's getting 2 times bigger every year. So the equation for species Y graph would be 25 times 2 to the x power. All right, next example. Okay, so we are just given a graph. Every exponential has one point in common. Just like, we said, what is the general graph of a parabola or a cubic function? And all of those had special graphs where they all went up 1 over 1 until we translated it. It's very similar here. Every exponential function starts at the point 0, 1. And if you think about it, like if say the base was 2 to the 0 power is 1. 3 to the 0 power is 1. 1/2 to the 0 power is 1. So whenever we input 0, we always output 1. And that's why 0, 1 is always on our graph. However, it's not always starting there, or we don't always have a point there because it's been translated. So we have to figure out how it's been translated. Another thing to think about is, remember, our horizontal asymptote comes from if something is being added or subtracted on the outside of our equation. So we can see that we have a horizontal asymptote at y equals 0, so we did not shift up or down at all. However, this initial point was shifted 1, 2, 3 over. So it started here and it shifted 3 to the right. So I do know that happened. There was a shift 3 to the right. So I'm going to move this back to figure out how it was before the transformation occurs. So I'm also going to move this point 1, 2, 3. Sorry, I'm writing with my mouse. Back. All right. So let's look at what the coordinates of these are. This coordinate here is at 0, 4, And the coordinate of this point initially was at 1, 12. So we can see a couple things from this. We have a point at 0, 4, and we have a point at 1, 12. So remember the y-intercept, which is 4, is always our a value. So I know I'm starting with y equals 4 times something. To get our b value, you look to see how much it's growing from basically like our last example in 1 year. So from time 0 to time 1, I went from 4 to 12. So 4 times 3 gives me 12. So it's growing by a growth factor of 3. Lastly, we normally would just do an exponent of x. However, I shifted everything to the right 3. So at this point, I would indicate that, and I'll actually make that go up if I can remember how. I mean, I don't think I just do that. I guess so. Okay. So I'd have an x minus 3 on top because I need to show that it shifted right 3. And this right here is your answer, 4 times 3 to the x minus 3 power. Again, the 4 came from what is the y-intercept, what is my starting value. The 3 came from I am growing by 3 each time. And then my x minus 3 is because my whole basic initial graph did shift right 3. So that is your answer to number 2. For number 3, it's very similar, except for on this one, you notice something different than the last one. We no longer have a y-intercept at 0, we have a y-intercept at 1. And this indicates that our graph from the original shifted up 1. So we know we're going to be adding a plus 1 to the end of our equation because our horizontal asymptote is up 1. The only thing that has moved is that this initial point here did not move left or right off that y-axis. So we only have to worry about moving that point then back down 1 to see where it started. So our point initially started here, and this point initially started here. So you're always going to move the opposite of whatever your transformation was to get it back to where it started from. Because we knew everything shifted up 1. So where was it before it shifted up 1 is what we're doing. So this point is at 0, 2. And this point is at 1, 6. So again, we can see, our x value is just going up by 1. So we don't have any like horizontal stretches or shrinks. And we can see that our y value started at 2 and it's now up to 6. So our b, or our growth factor, is going to be 3 again because 2 times 3 is 6. Our a, remember that's always your y-intercept, your initial value, which in this problem is 2. So our final equation will be 2, my a value, times 3. And instead of it just being to the x power, or I lied, this one is to the x power because it didn't shift left or right. Oh man, time out. It is just x. It didn't move left or right. So my x is just plain old x. But I did move up 1, and that's where there's that plus 1 at the end. So again, we move everything back. You have to shift it all back. That's the key. So shift it all back to where it was originally before any transformation occurred. Once you shift it back, find the ordered pair of the 2 coordinates on the graph. Determine if the x coordinate was affected or just the y coordinate. And in the 2 we've done so far, the y coordinate was tripled both times. So we knew we were growing by a factor of 3. Our y-intercept again is 2, so that's my starting value. My growth factor is 3, and I know my entire graph shift up 1, so I count for that at the end. Okay, let's do the next one. All right, so again, right away, I always check to see what the asymptotes are to check if I'm shifting up or down. And this one's y equals 0. So this one didn't move up or down. And you should also see that this one has a coordinate at 0, 1. So it didn't shift left or right either. It's still stuck in its place. So this coordinate, let's write our coordinates. This coordinate is at 0, 1, and this coordinate is at, what is that, 2, 3. So notice there's something a little bit different on this one. Instead of just our x changing, this went from 0 and jumped to 2. Our other ones were from 0 to 1. When that happens, that means we have a horizontal stretch of 2. So let me write that in. So because my x coordinates went from 0 to 2, we have a horizontal stretch of 2. So we're going to have to remember to put that in our equation. Then if we look at our y-intercepts, or y-coordinates I should say, sorry, we have 1 and 3. So notice it's getting 3 times bigger. So my growth factor, or what we call B, is equal to 3. And then of course our initial or starting point, which is the y-intercept, and this one is just at 1. So when we go to write our equation, we would have y equals my starting point. Y equals 1 times my growth factor of 3. And now I have to account for, keep doing this. Talking to myself. Would you expect anything different? I have to account for the fact that I have a horizontal stretch of 2, which, remember, this is opposite than what we would think. So instead of multiplying by 2, you can write it 2 ways. You could write it as x over 2, or you could have written it as like 1, oh Lord have mercy. You could have written it as 1/2 times x. It doesn't matter either way. It just has to look like 1/2, not 2, because we flip it. Oopsie daisies. I personally think it looks prettier like this, so I write it like that. Also, you do not have to write that 1. I just write it to be like consistent with what I've been doing. But remember, we didn't like add or subtract anything on this because we didn't shift up or down or left or right. And I knew that because this point was still sitting pretty at 0, 1, which it always does if it wasn't translated at all. Okay, I'm going to have to make a new video for the next one because it only allows me to record for 15 minutes, and I don't think I'm going to finish 2 problems in 2 minutes. So check out the next video for 5 and 6. And if you think you've got it already, make sure you watch it because it's like kind of intense. It's stretching, shrinking, up and down, and it's also one that is decaying instead of growing. So, all right.